What are the trade-offs of pure functions in JavaScript? Have you ever wondered about the trade-offs of using pure functions in JavaScript? Pure functions are a key concept in functional programming. They always return the same output for the same input and do not cause any side effects outside their scope. This makes them predictable and easy to work with, but they also come with some challenges that developers should be aware of. One of the main advantages of pure functions is their predictability. Since they rely solely on their inputs, their behavior is consistent. This makes reasoning about code much simpler. When you test pure functions, you only need to check the input-output relationship without worrying about external states. This leads to easier testing and debugging. Reusability is another benefit. Pure functions can be reused across different parts of an application without the risk of unintended interactions. This is especially helpful in larger projects where maintaining code clarity is essential. Additionally, pure functions enable functional programming paradigms like function composition and immutability, which can improve overall code maintainability. However, there are trade-offs to consider. One challenge is performance overhead. Pure functions often create new objects or copies of data instead of modifying existing ones. This immutability can lead to increased memory usage and slower performance, particularly with large or deeply nested data structures. Another trade-off is the increased object copying that can occur. When using pipelines that chain multiple pure functions, each function may create a copy of the data. This can multiply the cost of copying and affect efficiency. Integration complexity is also a concern. Interfacing pure functions with impure parts of an application, such as input-output operations or database access, requires careful design. This can add complexity to your codebase. In user interface frameworks like React, pure functions are commonly used for rendering components. While this can lead to predictable rendering, it may also introduce performance costs if functions are re-executed frequently. Using memoization strategies can help mitigate these performance issues. To address the performance costs associated with pure functions, developers can use techniques like memoization, which caches results of pure functions. Structural sharing, where parts of data structures are reused, can also help reduce copying. Passing state explicitly as function arguments and returning new state objects helps maintain purity but requires disciplined state management. Sometimes, a mix of pure and impure functions is necessary to strike a balance between maintainability and performance. Understanding these trade-offs allows developers to apply pure functions effectively in real-world web development. By being aware of both the advantages and challenges, you can make informed decisions when using pure functions in your JavaScript projects.